So I promised you I'd teach you how to predict the future. Well, here it comes. Let's see. Let's look into this crystal ball and see what we've got coming up in our near future. I see that word being used a lot, particularly in this video. It's two words, I know, common difference. Initial value, I see those two words being used a lot as well. What else do I see in your near future? I see finding the rule of arithmetic progressions, also very much in your future. What do I also see? Well, I can pretty much see you rolling your eyes from here. But anyway, this is a video to recap patterns and sequences, what we've been doing on Zoom the last little while. The first thing we did was I gave you a bunch of numbers like this, and I asked you to predict what would come next in this list. So by the way, just a sequence is a list of numbers laid out like this. And if I give you 8, 12, 16, 20, a lot of you figured this out right away, the next number would be 24. We're adding by 4 every time here. Here, the next number would be 148. Again, of course, if we're going too quickly, pause it, rewatch parts, move around the video as you need to. Here, something a little bit different. 4, 16, 256, 65,536. These numbers are getting very big, very fast. Here, we're squaring each number. You'd have to notice the pattern to figure out what this next number would be. Let's go back to this one. 8, 3, minus 2, minus 7. Next number would be minus 12. We are subtracting 5 every time. And here, minus 91, minus 81, minus 71, minus 61. The next number would be minus 51. Here, we are adding 10 every time. We can work with negative numbers, no problem. But the one that we're not going to work with as much in Sec 1 is this one, where we're squaring numbers. Let's postpone that for now. What I want you to look at most is these situations where we're adding a number. In this case, it was 4 every time, or if we're subtracting a number each time. But it has to be the same number. I'm not allowed to add 4 plus 4 plus 4 and then change it to plus 8. No, it has to be the same number every time. That number we mentioned is called a common difference. More on that later. So when a sequence of numbers increases or decreases by the same amount, we call it an arithmetic progression. And like I said, the amount that we go up or down by is called the common difference. When you head into Sec 2, it's possible you might hear different words for these, but for now, that's how I'm going to refer to them as. So in this example, 8, we go to 12, 16, 20. We are adding 4 every time we go from one number to the other. So in this example, the common difference is going to be plus 4. So here are a couple more. The next number in this is 38. Once again, the common difference is plus 4. Here, 143, 134, 125, 116. The next number in the pattern would be 107. We're going down by 9, so the common difference is minus 9. Here, minus 27, minus 22, minus 17. We're going up. The next number is going to be minus 7. How much are we going up by? Well, every step we're going up by 5. So that is the common difference. And then, this is how you're going to start to see numbers more often. They're going to be given to you in a table like this. Sometimes the top will be called the rank and the bottom will be called the term. But more often, the top is going to be X and the bottom is going to be Y. Okay, these are just really reference numbers. I'm not asking you to find the common difference for the rank or for the X. I want to know it for the bottom numbers here, the terms. So 19, 13, 7. The next number in this sequence would be 1. We're going down by 6 every time. That is the common difference, minus 6. So minus 5 would be the next number. And then if we subtract 6 again, we get to negative 11. So the common difference, like I said, minus 6. A couple more examples real quick. Here we're going from minus 5 to minus 3 to minus 1. The next number would be 1. The next number would be 3. Then the next number would be 5. Our common difference here is plus 2. We're going up by 2. Another example that we did in class very quickly. Numbers are bigger here, but don't be afraid of that. We're still going up by by one amount in this question every time. That's 17. So the common difference is plus 17. This one was a bit more of a challenge because I didn't give you all of the situation, but I told you the common difference. So let's go look at the minus 8 here, and let's go one space to the left. what number minus 7 would give me minus 8? Well, that's going to be -1. Let's ask the same question here. What number minus 7 would give me -1? Well, that's got to be 6. Let's go back to here. Now we can just keep subtracting 7 and fill in the rest of this table. And one more here that's really a little bit tricky as well, where I skipped over one and I didn't tell you the common difference, but I will tell you that this is an example you can do, that it's an arithmetic progression, that we're going up or down by the same amount every time we take one step. Let's see. Now, -4 to get all the way up to 6, that's an increase of, well, 10, okay? But let's see. I went a bit quick here, sorry. -4 to go up to 6 is an increase of 10, but that's over 2 steps. That means each step we're actually going up by 5. So from -4 to 1, we went up by 5. From 1 to 6, we went up by 5. Next number is going to be 11, continuing to go up by 5. Next number is 16. And this one that we're missing would be -9. So hopefully the patterns are starting to emerge. And what I want you to realize is that every time we're going up or down by the same number, these common differences never change for our situation. One more number I'm going to ask you to look for when you've got a situation like this is something called the initial value. This is the value when x equals 0. So look at the 0 for x and find the number underneath it. For this one, even though I didn't call it x and y, I could have, the initial value is -5. For this one, the initial value is 41. That's the number underneath the 0. Over here, the initial value is 6. Over here, the initial value is -9. So sometimes you're going to get this in word problems. Here's an example of one of these word problems. It says a student has a summer job mowing lawns. She makes $50 initially plus $12 for every lawn she mowed. I know my head is probably in the way of this question. I apologize for that. But $50 initially, and then for every lawn she mows, she'll get an additional $12. So what we're going to do, we'll make a quick table where we show the number of lawns and the amount of money she collects. So lawns will be the x-axis, or the x part of the table. Money will be the y part of the table. So the lawns, give you a few to start with. If she mows nothing, well, remember, she's making $50 before she even begins her job. So if she mows 0 lawns, she'll still get $50. If she mows 1 lawn, it becomes 50 plus 12. So she'll have $62. If she mows 2 lawns, it's 50 plus 12 plus 12, 74. 3 lawns, 86. And hopefully you can see the pattern that's coming here. What's the common difference? Well, the common difference, as you know, is going to be plus 12. We're going up by 12 every time. And what I want you to do now is I want to jump ahead. I'm not going to do 3, 4, 5, 6, 7, 8, or I am doing 8. Let's jump right to 8. If she mows 8 lawns, how much money is she going to make? And what you could do is you could expand your table and have it continue all the way to 8, but that's not always nice when the numbers start to get very big. What I've given you here is the rule of this situation. And a rule, very important, is a quick little formula that allows you to figure out the amount of money based on the number of lawns that were mowed. And it will work no matter what numbers we use. So I'm telling you the rule here, that if you multiply the lawn number on top, by 12, and then you add 50, you are going to get the amount of money. Whether it's 1 lawn, whether it's 8 lawns, whether it's 20 million lawns, that's going to tell you the amount of money. This rule will always be true. So if I do this, if I do 8 times 12 and then I add 50, I'll get 146. If I do 49 times 12 and then add 50, I'll get 638. And if I do 92,351 times 12 and add 50, it sounds crazy, but we can still do it. You'll get $1,108,262. So don't make your table this big. Use the rule. It'll help you. One more modest example. 17 will get you $250. And the way I want you to start thinking of it is, what if I just say X number of lawns? Well, I'm not telling you the specific number. So you've got to take X, whatever it is, and multiply it by 12 and then add 50. Algebraically, we would say it like this: 12 times X plus 50. So that X can be any number we want, but as long as we don't know its value, we're going to write it like this. Common difference is 12, initial value is 50, and we can write the rule as we show here. One more quick example of this. So here's a situation. You can probably tell the pattern already. Let's find out the rule. Well, there's a way that we can do this without me telling you that will work every time. The first thing you need to do is find the common difference. In this case, let's see, 13, 18, 23, 28, 33. We are going up by 5 every time. Next step is find out the initial value. Well, the number under the 0 is 13. Okay, so we are going to get, 13. The rule is always going to look like this. It's going to be common difference times X plus the initial value. So the rule of this situation is 5X plus 13. And the great thing about that is now we can use this rule to help us find out some much higher situations. If I use 93 as the number, well, then I'm going to do 5 times 93 plus 13. And if you do that, you will get 478. So the rule will always take on this format: common difference times X plus the initial value. So here's one more situation. Common difference, I hope we can see, is 4, because we're going up by 4 every time. The initial value is -5. So the rule is going to be 4x minus 5. If I give you 19, all we have to do is take the rule and replace the letter x with the number 19. And then we just carry out our calculation. So here it is with the number 19 replaced. If we work this out, we're going to get 71. What if we work backwards though? Well, we can do this because we know algebra. If I give you the y value as being 339, I'm telling you 4x minus 5 equals 339. What would be the value of x in this case? Well, we can solve this. In algebra, remember, you want to get the x by itself. First thing I got to do the opposite of -5. And the opposite of -5 is +5. And of course, whatever I do to the left, I also have to do to the right. So now I've got 4x equals 344 after I add 5 to both sides. Last thing I got to divide this by 4, because the opposite of a multiplication by 4 is a division by 4. And that means I got to divide that side by 4. And ultimately I get x must be 86. There we go. Much better than expanding your table to 86 columns is to show the math and use the rule. One more quick example here. The numbers are much bigger, but don't be afraid of big numbers. We're going up by 98 every time. The initial value, the number under the 0, is 121. By the way, be careful when you're doing the assignment. There is one of these situations where I don't give you the number under the 0. You've got to figure out what it would be, but you can do that if you see the pattern. Anyways, the rule, because it always follows this format, is 98x plus 121. So what if I want to know the 7th value? Well, you just replace the letter x with the number 7. And if you carry out the calculation, you're going to get 807. Now let's work backwards one more time. What if I give you 1,983? Well, we know the rule, so what we're saying is 98x, whatever x is in this situation, plus 121 is going to give me 1,983. So your job is to solve for x, find out its value. I got to get rid of that plus 121, so I'm going to do the opposite. Minus 121 on the left means I got to do minus 121 on the right. That means I've got 98x equals 1,862. And if I divide both sides by 98, I'm going to get an x value of 19. So there we go. I can give you any number and you can figure out the x value associated with it. Or I can give you any x value and you tell me the y value. You know it all because you know the rule. This is the part of the video where I'm going to show you how to do some graphing. You already know how to do graphs with a pen and paper, or pencil and paper, even better. But how do you do it with the computer? Well, there's this really good website that you're going to use a lot in Sec 2, 3, 4, 5, desmos.com. Head over there, try this out, click on Start Graphing, and we get taken to this nice, big, beautiful, empty graph. So you know how to do this. When I give you an X and Y coordinate, remember, we always do the X first, that is the horizontal axis, and then we find the vertical position along the Y axis. So what I'll do is I'll give you an example. We're going to add a table here. So I'm going to add X and Y values. Maybe I'll start with X at 0, Y at 3. Maybe I'll do for next 1. In fact, let's just make a bunch of X values right here. 2, 3, 4, 5. And what I'm going to do is I'm going to make an arithmetic progression. So if I have 3, next I'm going to say, let's say, I don't know, 7. Next is going to be 11. Next is going to be 15, 19, and 23. You can probably tell the pattern here. The common difference is I'm going up by 4 every time. The initial value is 3. And what this website has done is it's drawn all these points for me. I just need to zoom out a little bit. But if I zoom out, it looks just like zooming in and out of Google Maps or anything like that. And what I want you to notice is that these points rather, all form a nice straight line. So for instance, this is the point 1, 7. I've moved 1 space on the x-axis, so 1 space to the horizontally, and then we go up 7. Next, this is 2, 11. So all of these are points. And what is the rule of this situation I just gave you? Well, the common difference, as we said, is 4, and the initial value is 3. So what we could say is the rule is 4x plus 3. And check that out. When I type it, it actually draws a line right through all these points. Let's do one more quick example. Let's do another table. 0. Let's just do some x values. 1, 2, 3, 4, 5. I'm going to do 3, 1, minus 1, minus 3, minus 5, minus 7. What is my, what's my common difference? Well, I'm going down by 2 every time, so it's minus 2. My initial value is 3. So let's connect these. Let's do minus 2x, plus 3. And now I've drawn a line right through all of those points. So if you know the rule, you can draw it on a graph. You can plot the points. And what I want you to remember is that in an arithmetic progression, like the examples we've been dealing with, you should always see nothing but straight lines. There are other more complicated things, like x squared is going to cause this curvature. This is called a parabola, but you won't deal with that for a while now. Look for straight lines. That is a hint that it's an arithmetic progression. And one more fun thing that you can do with this website, let's just refresh it. Let's go to desmos.com. Some people who have a lot of time have done some really fancy artwork with this website. They've taken rules of nice arithmetic situations, but also a lot more complicated math, and they've produced all this beautiful artwork with it. Oh, this is one of my favorite paintings, now in graph form. How cool is that? All the coding, the math coding is over here. You only really know, I guess right now, the Sec 1 level, but by the end of high school, you'll be able to do some pretty impressive math. This is so impressive, it's taking a while to load. Maybe I'll edit this in the video, I'll speed it up. Whoa, how cool is that? Math meets art. Can it get any better than that? So before we wrap this up, let's do a couple of very quick word problems. More lawn mowing references here. It's almost summer and you're going to be mowing lawns as a summer job. There are 2 different mowing companies that want to hire you. And your goal is, well, you want to make as much money as possible. So you're going to choose the company that pays you the most money. So the first company, the Lawn Rangers, hilarious, I know, are going to pay you $50 initially, and they'll pay you an additional $10 for every lawn that you mow. Another company makes you another offer. The Lawn and Order Company, I know, funny again, will pay you $35 initially and $12.50 for every lawn that you mow. So which one is the better deal? Well, if you look at it, it depends. It depends on how many lawns you mow. If you're going to quit your job right away, I would work for the Lawn Rangers because you'll get more money at the start. But because Lawn and Order is paying you more for each lawn, eventually this one is going to become more paying. So let's make a quick table to figure it out. The number of lawns mowed and the amount of money. So 0 lawns mowed means we've got $50. If we've got 1, we've got 60. If we mow 2 lawns, 70. And you've got the pattern. So the next thing I want to do, I want to find the rule. Remember, rule is common difference times x plus initial value. Common difference is 10. We're going up by 10 every time. Initial value is 50. That's the number under the 0. So the rule is 10x plus 50. For the other company, we're going to do the exact same thing, but the numbers are different. When we mow no lawns, we've made $35. If we mow 1 lawn, we've made $47.50 or $47.5. 2, 60. 3, 72.50. The rule, once again, well, the common difference, every time I'm going up in this situation by 12.5. The initial value is 35, so the rule is 12.5x plus 35. You are allowed to have decimals in these situations. So what I want to do with this is show it on a graph. The green line is the Lawn Rangers. The purple line is Lawn and Order. A couple of observations, by the way. Where this crosses the y-axis, that is the initial value every time. So I can read from this graph that the initial value here is 50 for the Lawn Rangers, and for Lawn and Order, it's 35. And what I like about seeing this graph is I can figure out how many lawns I have to mow for Lawn and Order to take over and be the more paying job. Okay, but first, before we get to that, do these lawn companies follow an arithmetic progression? Well, the answer is yes, because they're going up by a certain amount every time. For Lawn and Order, it's plus $12.50 per lawn, and for the Lawn Rangers, it's plus 10 for every lawn. Those numbers are not allowed to ever change. The other way that we can recognize this is because the line is straight, or both lines here are straight. If you ever see a curved line, and you certainly will in math, if you ever see curved lines, it means that it is not an arithmetic progression, and that we're not going to work with it much in Sec 1. So here they are with the rules. And what I want you to figure out is at what point would you make the same amount of money no matter which company you work for? Well, the great thing about having a graph here is that we can see that these lines meet at the x value of 6. So if we mow 6 lawns, it doesn't matter what company we're working for, we're going to make the same amount of money. Okay? So $110, you can actually read that from the graph too. But what if I didn't give you a graph? You could draw one, and that's a good thing, you should draw graphs. But another way that you can do this is you can take the 2 rules and set them equal to each other. And then what we've got is an algebraic equation. We've done a few like this, and you can do this one and find out the value of x. So remember, you always want to get x by itself. I don't like seeing x's on both sides of the equal sign, so I'm going to deal with that first. Let's get rid of the 10x on the right by subtracting it. That means I got to subtract it on the left as well. That's going to leave me with 2.5x plus 35 equals 50. Let's get rid of this plus 35 by subtracting it. And if I do it from the left, I've got to do it from the right. Now I'm left with 2.5x equals 15. If I divide both sides by 2.5 to get the x by itself, I am going to get x equals 6. So you can do it with a graph. You could do it with a table and just see when we get the same answer, or you could do it algebraically now that we know how to do some algebra. And that's the point where they meet. So two more questions. Suppose you mow 35 lawns for the Lawn Rangers. How much will you earn? Well, again, all we have to do is take the rule and replace the x with 35. 10 times 35 plus 50 is going to be $400. This one you kind of have to use the rule because I don't really show it on the graph. You would have to zoom this graph out if you wanted to see the number 400. And one more question. Suppose you earn $1,047.50 working for Lawn and Order. How many lawns did you mow? Well, here I'm giving you the final answer and I'm asking you to find the X value to work backwards. In other words, a little bit more algebra. Here's the rule and here's the answer. You need to find the value of X. So we do this algebraically. Again, get the X by itself. I'm going to subtract 35 from the left and from the right. Now I've got 12.5x equals 1012.5. Last step, I got to divide both of these by 12.5. That'll get the X by itself when these cancel. And I'm going to get 81 lawns. So if you mow 81 lawns for Lawn and Order, you will make $1,047.50. So there you go. I told you I'd tell you how to predict the future. See, you can predict that when you mow 81 lawns, you can predict right away how much money you're going to make because you know how to do this situation. Tell your friends. So with that, try the assignment. It's now available. Be careful with a couple of the questions. Email me if you have any questions. And with that, this is going to be the final math video. So thank you for watching. Like and subscribe. You know the drill. Read that. Wash your hands. Be safe. Take care. Goodbye.